Hi again. My name is Stanley, and in this lesson, static views come to life as we explore the relationship between XML layout files and the activities that display them. During project creation, Android Studio spared us the trouble of associating the activity main.xml layout file with the main activity object. The two are associated not by name, but by the setContentView method found in the activity class. This complex method accepts a layout file resource identifier, generates the views designed within, and presents them on screen, a process known as layout inflation. If we remove this line and rerun our application, we'll see that main activity still presents something, and that something is known as the decor view. We removed set content view to prove one critical point. Android does not require activities to present any view at all. Even the decor view is optional. However, unless otherwise specified by the application's theme, all activities produce a decor view, and we may manipulate this view programmatically by first invoking getWindow. An activities window is much like an application window on a desktop operating system, such as OS X or Windows, but without those little X's in the corners. Activities request a window object from the system and draw their content within. And the window object exposes the getDecorView method, which returns the top-level view group object in which activities must place all their visible content. To prove we can manipulate this view, we will change its background color to this mysterious hexadecimal value 0xFFFF0000, otherwise known as the color red. When we invoke setContentView, we pass the layout file or view object which main activity displays as a child of this red rectangle, the decor view. And currently, our layout lacks anything, well, anything. And if we're being completely honest with ourselves, that's a non-starter. What we want is to include CardViewContactCard main.xml as part of main activity to show off actual contacts and prove that we have friends and stuff, because we totally do. By using include components, we can present a couple of contact cards on the screen. Normally, we would create this type of layout using a recycler view, a special view group that allows us to build scrolling lists. But for the sake of this example, we will hardcode exactly two contact cards into activity main. And to put some much needed space between these cards, we introduce the space component, a view which allows us to add a gap of arbitrary size to any layout. Whoops! Any attributes set using the tools namespace do not appear when running the application, so we need to set values for our contacts avatars using the Android namespace. Clicky here, clicky there. And we'll use the largest drawable, which came bundled with our project, IC Launcher Foreground. We require one last tweak before we can manipulate these contact cards inside main activity, resource IDs. Includes are not view objects, and we'll prove that in a moment. However, we can assign unique IDs to includes, and these IDs transfer onto the layouts included within. Now we're ready. Remember, setContentView converts all the XML components in our layout into Java view objects. So after this method returns, we can access any view object from our layout programmatically. To find a specific view object, we invoke the findViewById method. This method returns an object that inherits from the view object, or view itself. To verify that includes are not a type of view and that findViewById in fact returned a CardView object, we can use Android's built-in logging system. To get started, we need only type logd, shorthand for log debug message, and hit tab. Logd expects a variable named tag, and Android Studio notifies us that this variable, in fact, does not exist. When we highlight a problem and press Alt-Enter on Windows and Linux or Option-Enter on Mac, Android Studio reveals a few suggestions. We'll create the tag variable as a constant within main activity because we will use the logging system multiple times within this object. As for our message, we'll print the full class name of contact card 1 and rerun our application. To find our message quickly, we filter for main activity tag, the first parameter we passed to logd. Aha! Contact card 1 is in fact a card view. We have the card. Our next step is to set the contact's name, and it's good practice to double check the name of the ID we assign to the view. TV Contact Card. Perfect. Normally, we retrieve contact data from the Android Contacts API or private user data stored in our application. But to support this example, we will hardcode two contact names right inside of main activity. Real classy. All view objects inherit the findViewById method as well, and we retrieve our first text view by calling findViewById on the card view itself. Now that we have it, we need to invoke the setText method to change its content. To do so, we start a statement with contact name 1, add a dot, and then let autocomplete do its. SetText is not part of the base view class. It is only found on TextView and views that inherit from TextView. To fix that problem, we need only change the type of contact name 1 to TextView, and then try again. Notice that Android Studio highlights the methods defined by TextView in bold, whereas methods inherited from the base view class do not receive this emphasis. Now we're seeing the results we expect, and we can repeat this pattern for our second contact card. Activities may present views, and invoking setContentView is the standard way to display a layout to the user. After layout inflation, all XML components become programmatically accessible view objects, and we can retrieve and manipulate them using findViewById.